welcome to the stream. If you are new here, it's Jared. I am a Ruby programmer. I run an agency called Supergood Software where we build e-commerce systems using a platform called Solidus that's built on top of Ruby on Rails. Just like last year, I'm attempting to do all of the Advent of Code Christmas-themed programming puzzles. We have just finished day 18. It was a tough one. The tough part was primarily that I had a really subtle bug that was really, really hard to find, and I picked a really bad way to find it. But we did find it with the help of chat. Eventually, we tracked down the issue and solved it. Part 2 was really easy once we managed to get part 1 working. Told day 20 is comparably easier than 18 or 19. Allegedly, someone told me that Eric tries to make the weekend puzzles harder because he figures people have more time. Makes me wish that I'd spent more of my weekend on those puzzles because we have to do day 19 now, which told is just is comparable to 18. But hopefully that means we're in the finish stretch because Christmas is a Saturday, so it's this Monday, Tuesday, Wednesday, Thursday, Friday, yeah. And 25th is always sort of just a check to make sure, a simple puzzle and a check to make sure that you've done all the other ones. So looking forward to that. Well, something to do on Christmas Eve. I don't think we have anything else I wanted to touch on, so we can move over here. Oh, I'm gonna have to fix. So I had to restart my computer. So I need to go grab my session cookie and make sure I don't show it to all of you. I'm going to do that before we dive into reading the problem. I have a thing that like automatically downloads the puzzle inputs because they're different per person. And I need my session cookie to be in the environment. But I also need to not show you all. I'll show all of you my session cookie because then you could log in as me. Sure it's working. Cool. Okay. Yes. Okay, that worked. All right, let's get back to it. Ooh. Almost showed you my session cookie. My browser tool is still open. All right, let's get down to it. As your probe drifted through this area, it released an assortment of beacons and scanners into the water. It's difficult to navigate in the pitch black open waters of the ocean trench, but if you can build a map of the trench using data from the scanners, you should be able to safely reach the bottom. The beacons and scanners float motionless in the water. They're designed to maintain the same position for long periods of time. Each scanner is capable of detecting all beacons in a large cube centered on the scanner, beacons that are at most 1,000 units away from the scanner in each of the 3 axes. Have their precise position determined relative to the scanner. However, scanners cannot detect other scanners. The submarine has automatically summarized the relative positions of the beacons detected by each scanner, your puzzle input. For example, if a scanner is at XYZ coordinates. Oh, am I going to say Z or am I going to say Z? I just realized I said Z. I mean, normally I am Canadian. I would normally say Z, but I feel like, I don't know. For coordinates, sometimes I just say Z. And there are beacons at minus 500, 1000, negative 1500, and 15010, negative 500. The scanner could report that the first beacon is at 1100, negative 1000 relative to the scanner, but would not detect the second beacon at all. So it's 1000 away, it's another 1000 away, and it is 1000 away. Okay, that makes sense to me. Unfortunately, while each scanner can report the positions of all detected beacons relative to itself, the scanners do not know their own position. You'll need to determine the positions of the beacons and scanners yourself. The scanners and beacons map a single contiguous 3D region. This region can be reconstructed, finding pairs of scanners that have overlapping detection regions, such that there are at least 12 beacons that both scanners detect within the overlap. By establishing 12 common beacons, you can precisely determine whether the scanners are Yeah, I bet. By establishing 12 common beacons, you can precisely determine where the scanners are relative to each other, allowing you to reconstruct the beacon map one scanner at a time. For a moment, consider only two dimensions. Suppose you have the following scanners. Scanners specified there, drawing X increasing rightward, Y increasing upward, scanners as S and beacons as B. Scanner 0 detects this, scanner 1 detects this. Yeah, makes sense. And I can see the overlap. For this example, assume scanners only need 3 overlapping beacons. Then the beacons visible to both scanners overlap to produce the following complete map. Yes, that makes sense to me. Unfortunately, there's a second problem. The scanners also don't know the rotation or facing direction. Due to magnetic alignment, each scanner is rotated some integer number of 90 degrees turns all around the X, Y, and Z axis. That is, one scanner might call a direction positive X, while another might call that direction negative Y. Or two scanners might agree on which direction is positive X, but one scanner might be upside down from the perspective of the other scanner. In total, each scanner could be in any of 24 different orientations, facing positive or negative X, Y, Z, and considering any of 4 directions up from that facing. For example, here's an arrangement of beacons as seen from a scanner in the same position but different orientations. By finding a pair of scanners that both see at least 12 of the same beacons, you can assemble the entire map. For example, consider the following report. Because all coordinates are relative in this example, all absolute positions will be expressed relative to scanner 0 using orientation of scanner 0 as if scanner 0 is at coordinates 0, 0, 0. Scanner 0 and 1 have overlapping detection cubes. The 12 beacons they both detect are these ones. The 12 beacons, scanner 1, because of this, scanner 1 must be at this coordinate relative to scanner 0. Scanner 4 overlaps with scanner 1. 12 beacons they both detect are these ones. Scanner 4 is at their coordinates. Following the process, scanner 2 must be at these coordinates. The full list of beacons is those. Total 79 for this test input. Assemble the full map of beacons. How many beacons are there? Okay. Seems fun. Got 3D maps that we don't know the orientation of, and we have to orient. Very long test input. So Need to bind a sneeze button or something on my mouse. All right. So, we have, this is day 19 that we're doing. We need our day 19 specs. Oh, I muted myself during the sneeze. I was just really quick in switching to OBS and muting myself. And then we have this test input, which is this thing. Nice. Okay. Probably wants more, right? Some more fine grained specs than this, but we can start with this. So we're expecting to have a input file. So I want to build some scanners out of the input. We'll split it on double new line. That'll give us each individual scanner. And then within here, we'll want to grab the name and the beacons. And this will be the scanner. It's split on new lines. And then we'll construct a new scanner from, and it'll have a name and beacons will be beacons split on, so these are already bunch of lines, so we're going to want to turn them into an array of integers. So we'll split them up commas and map them to integers. So now they're 3 integer coordinates. I'm not exactly sure how we're going to build up this result, but we can start with this. So we'll want a class scanner. Get some name and some beacons. I don't really think we need the name, but it'll allow us to tell them apart. That could be useful for debugging. Script there, and I think I want to just pull out the actual that'll get me what I want. Let's see. Oh, and let's here. Let's just focus this. I want to care about right now. Get some things wired up. Name, cool, that works. Beacons, cool, that works. And this will happen times or 5 times or something. So now we just do something with the scanners. I think what a good way to scan all the possibilities is. There's just quite a lot of them. Man, this is. Hmm. What's a good way to search these? I'm just trying to think if there's something clever we can do. I like clever solutions for these. Because, like, we can. How do we evaluate a given orientation? Guess we can sort of like tricky. Thinking of too many ways that require looking at too many things. Jeez. My friends got on both day 1 and day 2 leaderboards for this one. I'm using Ruby. I'm a Rubyist. And I can iterate over all of the points in one. Check to see if they could be points in the second in any orientation. And then return. And then if I find an orientation that works, so like, for example, so like, yeah, these two are the same. Just trying to think, how could I? That's a fun way to do it. I've always thought about doing it in JavaScript just because it would be nice to have HTML as a visualization engine for progress. I don't normally do any kind of visualizations or anything. I'm told that the weekend ones are the hardest, so this might be the hardest puzzle we see this year. Maybe also the vector class. I'm trying to think if this will be useful at all. I think it might be. We'll play with the vector. See what we can do with it. I feel like this is going to be useful. Matrix. What's the constructor take? Create a vector. Okay. Yeah. That's what I'm thinking. Oh, it wants me to do weird syntax, sure. Okay. Doesn't like that. How do we want to do? Okay, so I can do. I don't remember how cross product works, but that was fun. What's cross product again? It's been too long. It's been like 10 years since I took this in university, maybe more. Two linearly independent vectors, yes. Vector that is perpendicular to both A and B. Okay, well, that's good to know. Well, that makes sense to me. plus works. How I vector addition, yeah, that makes sense. Subtraction. Angle width, cool. Not useful to me, but neat. No, crossbar is probably not useful now. I realized that as soon as I looked at it. As soon as I read what it was. How do I... Normalize do. Oh, yeah, that makes sense. Wait, rotate a vector? Does this work again? I'm so far out of vector math here. Oh, this is too much. This math is too hard. Nope. Point 1 minus 0.2 for distance. 1 minus 0.2. Yeah. What is that gonna get me? With the distance. Oh, come on, brain. Trouble visualizing this one. Maybe I should look at the 2D example. The 2D example is already rotated. Makes sense. Let's just go look at it. Oh, I mean, I'm not personally worried about spoilers at all, so don't worry about that. I'm just trying to think of what my actual approach is for this. So I can... How can I decide if two given points could be the same? How do I like... What's the best way to do this? Like, assume 2 points are the same point. Attempt all possible orderings of the coordinates from one set against that point. see if we get 12 matches or something like that. Oh, that's gross, but I want to find an easy, clever way to do this, not just a nice big brute force. Okay, fine. You made a distance index A, index B map. Okay. Yeah, I mean, one of my friends had a solution that took many minutes to run and then managed to optimize it down to a few seconds. The resolved ones. Yeah. Sorry. Here's beacon. So we want to, let's sort of pseudocode out this thing. We want to compare, I mean, start with no beacons resolved. Compare beacons defined 12 matches. Yeah, I bet. Set those or sorry, resolve those beacons. Search for more, search through additional beacons. Yeah, this seems non-trivial. I'd be curious to see what I've got one guy on my team who's a Ruby golf machine, so I suspect today's is a little too tough to get it down that small, even doing some Ruby magic. Search through additional beacons to find another match. Resolved. Repeat until all resolved. Count. Okay. We can say we have. Let's put a map is just going to be hash. I'm probably fine without looking at other people's solutions right now, but appreciate any help you give here. So we can set a map where I'm just going to set the keys to sure. Does this need to be keys? Actually, no, let's just use a set. So we'll use a set. That's just going to contain all our resolved points. Seems like a reasonable way to do that. And we're going to say our unresolved scanners can go in here. And we'll just remove them from there as we go. So that covers our start with no beacons resolved. Then we want to look for unresolved, kick ourselves off by iterating through the unresolved combinations of 2. Using that, we'll, if A is congruent, use congruent here, with B, or sorry, we can just next. A is congruent with B, or we can use find actually. Why don't we do that? So that'll do that. Then what do we do here? So we need to get them into that unresolved map set. So I guess we can do something like map I don't know what the set API looks like. It's I have an array of values and I want to add to them. Can I just add? I can't add as long as it's an enum, array is an enum, so I can plus equals this matches first beacons. So that puts all the beacons from the first scanner we found that matches, and then we're gonna have to do something like something clever maybe, where we add matches second dot align beacons with our current map. Then we'll unresolve delete matches first. All right, so I don't have the second. I only have the last. That's resolve those beacons, and then the scanner class will be doing all the work. So going to be something like unresolved dot find, or sorry, until unresolved empty. Going to want to, what do we want to do? We want to find unresolved. Is congruent. It's going to take the beacons so that I can pass it. So I can use my resolved set or my map. Find so what's it called? Scanner. Scanner is congruent with map. And we're essentially doing the same thing we did here. So this is going to be scanner, and this is going to also be scanner. And we're going to remove map dot. Okay. This seems vaguely like if I wrote a whole bunch more code into that scanner class, that maybe it would work. I find method combinations for, but that was an array. I thought arrays. What's combination? Well, confusing name, rename that, but okay. Find method beacons for a string. I've used each here, so map. So let's just get rid of all of the. Okay, now we're getting the error we get is congruent with sure. Okay. I'll just return beacons here. Okay, you resolve. Amazing. So gets through all the code, but naturally we're not actually correctly checking this, so we're not correctly aligning our beacons. Let's just make it a checkpoint here. Day 19. Part 1 runs, but is wrong. Yeah. It's the easiest way to make progress here. I'm just thinking about like whether I want to write some more tests around the scanner class to help me make sure it works right. So we've got a lot of different ways of arranging just trying to think of all the different. So we've got x and negative x. Positive y, negative y. And then, so for every possible one of these, there's a whole host. So there's Xdir, Ydir, Zdir, mutations. Oh, it's going to be permutation. So this is, I have too many. Right, there's only what, 24. Am I missing? Scanner rotated some integer number of 90-degree turns all around X, Y, Z axis. That is, one scanner might call direction plus of X from the right. Call that direction negative Y. Or two scanners might agree on the direction is positive X. One scanner might be upside down from the perspective of the other scanner. What is... Ooh. Streamlining back online. Here we go. How many of these did I generate here? Oh, that's okay. Must have flattened it. Okay, so I have exactly twice as many as I should have. That's what it looked like, eyeballing it. It must be something. So some of these must not be valid, but what makes them not valid? Chat, please, if you know the answer. Why can't I look at all the positive and negative variations and rearrange them? I'm sure it's just geometry means that it doesn't make sense. It's because this is rotation. This isn't just arbitrary possible options. I just don't know how to generate the possible options. So like, I've got it. I'm doing a lot of this with my hands. I figure it out. I sadly don't have a Rubik's Cube handy. I should probably start trying to visualize this. I have, this is, I rotate it over, this remains plus x. This is now y plus z. This isn't helping my brain think about this at all. The thing I'm struggling with is just how to figure out which ones aren't valid. Like what the actual logic for iterating through all the possible valid values. Because I guess I can rotate my head, my earpod or my AirPod case. I mean, how do I visualize this? I guess this is range positive x. Let's talk about what they actually are now. Call them A, B, and C. So that's rotated that way. We can continue the rotation. But vaguely similarly. So A remains plus x. B is now minus y. And C is now minus z. And then last rotation for this orientation. That A continues to be positive x. B z, and c is now y. So we produced permutations where it's x, y, z, x, z, negative y, x, negative y, negative z, and x, negative z, y. That's by rotation. So we can also rotate these along any other axis. I need to just implement the rotation logic. That doesn't seem cool. What is causing me to have exactly twice as many orientations in my thing, though? What invalid result is there? So let's see, let's take this one, rotate it this way. So now it's, and C is negative Y. X, A is now negative X. P is negative Z. So the all negatives rotation exists. Guess there's no way for me to get C over to negative Y though. There's no way. This can't work. Yeah. How do I iterate over them to avoid mirroring things? Is there an easy way to do this? Only 24 things. I pre-calculated them as matrices. Okay. I am, okay, I'll admit I'm curious. Can I see yours? I don't want to be here all night. Yeah, I feel like I could sit here and draw out all these rotations, but sorry, just proofreading that I'm not putting anything questionable on screen before I show it. I guess that's a fair argument. You could just do that, yeah. Okay. So these are okay. And then this is going to do the multiplication of a matrix times a this is very difficult to read, but it's good. It's good. Yeah. Okay, well, get back to our good friend, our vector, and then also take a look at the matrix code, because we haven't looked at that. Oh yeah, no worries. Definitely still appreciate it. So if I have the matrices, it's valid, Ruby. Yeah. I can even just put those in a constant here. And it just not like syntax having that for some reason. Standard RB. Okay, there we go. Sorry. And then we want to map these to be matrices. I think we're gonna have to require this file. And then this, the constructor is this another one that wants us. Oops. New rows concat. Okay, so it wants us to use that other syntax. Move that. Let's just see what we got here. All right. Code works. And so this first one should be yeah. Let's grab a different one. This one should have nice. That looks like it's all doing the right things. Let's try a harder example. Now, There we go. Okay, that's what I wanted to make sure it was working correctly, or presumably working correctly. So I don't know which one 15 is in there somewhere though. Okay, cool. Now we have something to work with. Thank you, Narf. So now we can do something. We can do something with orientation. So we can do like matrices. Don't actually need that to find identity, eh? So I guess now, am I correct in understanding that if I have a bunch of different points in space and I find the correct orientation with another one, then the subtracting those 2 points is always going to give me the distance between the two. I just had to wave my hands in there. Subtracting the 2 points is always going to give me the distance between the beacon, between the scanners. So we're going to get like 12 of the same number if we figure out which ones to subtract against each other. Does that help though? Or am I just going to go through too many of them? Too many combinations, because it could be any of them. I don't know which point. So that doesn't help with which points are which. Yeah, cool. That part makes sense to me. Apologies, checking in on a production incident someone else is handling. Cool. This makes me wish I'd pay more attention in my matrix algebra class. Okay. So now I can iterate over orientations. And yeah. So I can try all the orientations of one of them against another, against the other beacon. I guess I try all the orientations of this one, so I can say, I guess if I want these beacons converted to vectors. Easy enough. Does vector identity work correctly? If I have two vectors that are the same, just want to make sure. I would assume they do, but I need them. I definitely need them to if I want to use sets. Okay, cool. So for any of these, we can then produce a set of points or a set of vectors in that orientation. I knew that M1 because I was thinking I would need multiple orientations, but I only need to test one. And then how do I match them up? I've got a set of points. Just pick one. This is where I'm curious as to how brute forcey we can get. Oh yeah, I guess I never actually looked at the input. I should do that. Usually I'm good and remember say, okay, look at the input, make sure. Okay, so they only have however many that is, like a couple dozen each. Cool. My concern is if each point could be any other point in the resulting set, or like in the other set of beacons that we're looking at. I guess we scan them looking for. So we pin a pair. So we and then we look for. Oh, break my brain. Okay. So we need to iterate over oriented beacons, and then try pinning every beacon in the other beacon. Oh no, they're both called other beacons. One. So I'm still having trouble seeing through the solution of this one, but try it. So oriented beacons each be one, be two. So the distance is b1 minus b2. That's the distance we're looking for, and we know that at least 11 other beacons should match up, right? Oh boy. So can we do something here? Can we do something with count? So for every combination of B1 and B2, if we pin those together, we want to check that there are 12. Just need to match all the beacons inside of here though. Besides those ones. This doesn't seem right. But I'm gonna keep typing until I realize what I'm doing wrong. So we're trying to count. This doesn't make sense to me. We want to do something. Wait. So this orientation is congruent, then adding distance to all of, either adding or subtracting the distance to all of the points in B2 is going to, like, we could just do the union of the sets, right? This is going to because that's the transform we're looking for, right? Okay. Oh boy, brain working now. So reorient, not reorient, what do I call this? Transformed other beacons. So we can do other beacons. Map B either plus or minus D. I'm sure I'll figure out the answer at some point. So we want sets. We just want to use sets everywhere. Sets are good, because we know the union of these two sets is going to have at least 11. If we're matching, if the union of other beacons map and oriented beacons. I might have this totally backwards. Let's just. I mean, let's just. Hypothetically, we should hit that if I did it right. No, dimension mismatch. Okay. Where are we hitting that? Line 44. Matrix times vector. Okay. thing is right. I mean, that feels like we did the right thing. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. Oh, we can even see. Uh-oh. These. Okay, are they rotated? They're just rotated differently. Spooked me for a sec, but we're in -1, -1 land. Dang, that works. Oh yes, thank you for the help. Very appreciated. Okay. So that determines. So what we really want to do is return the rotation, and so because we're going to need to use this information. Anyway, we'll move on. So this is gonna last forever. So let's write a method to align beacon. These both align beacons and is congruent with. I mean, maybe we can get rid of is congruent with completely. And just have align beacons return the aligned beacons or nil. That way we can save ourselves some work here. What am I doing? Each scanner, we'll just align beacons map. So call beacons map. Next, unless beacons. So if we get into here, we'll want to add our beacons and delete the scanner and break. Okay, we need to fix this code so it doesn't use on beacons either. And we're just doing basically the same thing in this loop. But instead of A and B, with scanner, we have A, and so we have B dot beacons. Maybe. Oh, that fix this. Okay. Not pretty, but I think we're getting there. And then the other thing is these. Oh, what's the best way to set? Okay, that takes Okay. What horrible mistake have I made? Not even valid Ruby syntax. Good stuff. Yeah. Goes on the outside. Cool. Okay, so we're back to where we were. Line beacons needs to be rewritten with our working logic here. Is congruent with doesn't exist anymore. So I'm gonna return. So this means we found a congruence. The only thing is I want no, this is fine. This is fine. Still is going to require some thinking. Let's put a binary pi in here and just examine the situation. So we have oriented beacons. We have other beacon. And we know that if we map our other beacons across a distance, we get oriented beacons. Now, just to make sure I'm thinking through this straight, do other beacons and we do oriented beacons, we should get what's an array? Which one of these is an array? I think it should be an array. Other beacons, oriented beacon is an array. Why did oriented beacons become an array? Does mapping it turn it into an array? Beacons. So call to set on again. Oh, that's annoying, but never finish. And this probably doesn't matter, but beacons and sets, since we know they should never contain duplicate elements, which make things like deletion faster. Back here, we already know what's happening here. So we have other beacons. And this is going to be greater than or equal to, it should be 12 because we're doing it for all of them. We're just using B1 and B2 to figure this out. Let's fix that before I forget. Okay, so we found the matching way. We found the direction that our beacons so I think I need to do the opposite of this operation, right? I want to be converting our beacons, our oriented beacons. But it's going to be that. Okay. So that's the more useful thing. I think you just want to return the map from the left side of the and there. Yes. I think now I was transforming the beacons that I was trying to align with, not the ones that I was trying to align. That's what I was trying to fix. But yes, now that I fixed it, absolutely right. So we'll say intersect and equals. Yeah, I don't reorient. I think it's terrible naming. My real code person. Sure, translate it. Thank you. Beacons equals this thing. And then we just return translated beacon. Surely it can't be that easy. Oh, it's not fast. Could be looping forever. Oh, no, it works. All right. How do I get 19 examples? Do I have to focus on off my... I do. Let's just focus here. So that is not fast. But it is fast enough that maybe it'll finish. So one concern I have is as we build the map, we're just comparing it to we're comparing each one to the whole map. Not just individual beacons or individual scanners. Okay. I'm gonna run this in another tab, see if it finishes. Then I'm gonna come back to that. I want to let's just put this in here. Well, that's upsetting. That's very slow. My concern is that as it keeps going, it's going to get slower. My concern seems valid. Input order matters too. Kind of all over. Well, you can stare at that, but keep that finding, keep that in for the purposes of seeing if we make this faster. I'm going to recompute all of the possible orientations on each one here. We definitely, on each call to align beacons, don't need to be regenerating all of these. equals MHC's map. Do orientations that each do oriented beacons. A little bit faster, maybe. We're still looking at this. We're still looking at the same amount of stuff. We're just doing a bit less computation. So I found that faster, certainly. Doesn't seem like meaningfully faster. I guess I should double check that the specs pass. Okay, they do. What if I compare each one against? So one thing, if I understand the puzzle correctly, and maybe I can make the assumption that scanners and beacons map a single region can be constructed by finding pairs of scanners that have overlapping detection regions. So I don't need to look at the whole set. I can just look for additional pairs that match figure out which ones match the ones that I've already found, which I think I need to do. Unless that decides to finish one day. So, love making these ones. This is day 19, but part 1, but too slow. Okay. So let's say resolve equals nothing. And what if align beacons, instead of returning the beacons, so we're not keeping track of all the beacons anymore. We'll have to at the end, but entire resolve field. Yeah. I'm sure I'm doing something really slow. One of the things, it's as much as I love Ruby, it ain't fast. We had to bust out flame graphs on day 15 in order to get my dextras down to a acceptable performance level. But I've already not made the mistake of calling count on it, which is big O and not big O1 like sizes. Because it's an enumerable method, it's not a set method. Anyway, regardless, I think we can hopefully. I mean, we'll see if this finishes eventually. I want to run faster than that. So if we have a resolve set, we can shovel be in there. And we can, let's just do the lazy, I don't know. And I'm actually going to convert this to a set as well because the delete performance is faster on sets because it knows it, because they're essentially just hashes into the hood. I think the thing that I did that made it faster was keeping the congruence check to something that returned only the 12 matching pairs. I'm not sure I follow you. What am I trying to do here? So I want to do, see if I compute the distance map from all the resolved beacons to all the other resolved beacons to all the other resolved, and compare that against the scanner's distance map, looking for 12 matches. Then when checking orientation, I only have 12 by 12 to orient to find the orientation. So I can read the distance map from all resolved beacons to all resolved beacons. Oh, interesting. That's an interesting way to do it. Oh, well. That doesn't seem like it could be right, but we'll put it in. Oh, it is right. Okay, well. I guess, oh, sorry, I was thinking 35 times like 25. Yeah, that makes sense. So it took us 8 minutes and 36 seconds for our first run, which I consider unacceptably slow. So I want to, because the magnitude of the distance vector is going to not care about orientation at all. Magnitude of the distance vector. I think I'm having trouble wrapping my head around why that works. I think I'll complete this refactoring and then I'll try to think harder about that. Okay, so we go through the results. So we take the unresolved ones, we go through each resolve scanner. We try to align it against that one's beacons. And then this, we're gonna have to do something here. Okay, so now Align Beacons is expecting to return a new pal. Beacons rearranged to match. That's a lot of red. Combination for set. Okay. I guess we don't convert that to a set then. Shouldn't matter. Performance on that shouldn't be significant. Wrong number of arguments for self. I did this last night too. Uh-oh. We shouldn't find. That's what we. I don't think that makes sense. Oh, I was worried about the scoping on that. Wasn't sure if that would work. Figure out what's going wrong here, but why we're finding alignment so many times. Once one is aligned, we don't care about it anymore. Oh, did I move the? I removed the return. I removed the return. So, oriented. Sorry, no, what did I call this variable? Resolve. Blank. Or sorry, the size. 5. That's right. Map. To their beacons and take the union. Oh no, that's an ugly piece of code. And get its size. Oh, that didn't do what we wanted. I think you put intersection. Oh, yes. Yes, I did. Right. Thank you. You needed that one? I think that's the right answer for the test puzzle. Thank you. Well, it's something more I meant to there, but let's just take an eyeball at how much that has changed the performance characteristics of this thing. That seems like it hasn't much. But it shouldn't be finding the first pair any faster than it was before. Excuse me. That's not fast. That might even be slower. Yeah, I get that. Still missing something. I don't think looking at your code's gonna help me here. Okay. Resolve points 0 shares 12 distances to other resolved points with scanner points. You know, 0.0 is 0.12. Yes. Because you only find 12 resolved points, 12 scanner points to test on first. Got a point. Or cilantro, whatever my head around that. I mean, I guess the path I went down to not do it against all of the other numbers probably just, or all of the other, probably just made mine slower because I'm doing this, I'm doing way more work now. This is just, I was like, hey, let's create a big loop and do more work. So I think that was a mistake. And kind of undo that change. I guess recreating this that over and over again is probably not, is a waste of time too. I'm just trying to like, struggling to wrap my head around what you're telling me. Resolved equals scanner 0 rather than having first combinations that don't think will save time. Oh yeah, that's a good point. Thank you. So let's fix this thing. Resolve beacons. Wait, no, I wanted to just be an RSpec, not resolve this thing. Slow. And then we want to nuke this thing instead. Just pick. Unresolved. Okay. That didn't seem at all meaningfully faster. But I wouldn't expect it to be, just a little simpler. I don't know what kind of variance we get by varying the order that we do this in. We're going to see like some really fast runs if we just get lucky on an ordering. Guess it doesn't really matter. I'm not really going to leave that shuffle in there. I feel like it's on track to take less than 8 minutes though. What, 4? It's been running for less than a minute. 5 now. not much faster. On failing out of your loops. Did not match cases taking on time. Yeah, I think you're right. Okay. That makes sense to me. So is there a better give up case here? Is that what you were trying to lead me towards? That I can do like this align beacons method a lot more efficiently? So if I look at these oriented beacons and the other beacons, I think I understand what you were saying. So in maybe anyway, in here you're suggesting that rather than do this loop where I pin them all, I can, almost, my brain almost had it. Have man. I feel like I'm so close to something useful here. Oh, that. Just do something smarter here. Obviously the play. That is brutally slow. What am I missing here? So if I take trying to understand. For a given orientation, if one of these beacons has the same distance to all the other beacons that an existing, that to a bunch of other beacons, oh man, Come on, brain. Almost to a solution that optimizes this, but I still feel like I'm looking at all the other beacons. For anyone who's, I didn't realize we're all the way up to 6 people. For anyone who's just tuning in, looking at Advent of Code day 19, we have a solution that works for part 1. We have solved part 1. Help of Narf and Narf 37 in the chat. This is their solution that I was looking at. I've not clicked. I'm gonna click part 2 because I'm curious. Sometimes it's a good idea to appreciate just how big the ocean is. Using the Manhattan distance, how far apart do the scanners get? In the above example, scanners 2 and 3 are the largest Manhattan distance apart. In total, they are that distance apart. What is the largest Manhattan? Any 2 scanners, okay. So we're gonna need to make this fast to do that part 2. Faster than 8 minutes 36 or whatever this is gonna turn out being. That is technically true. And I would argue a pretty hilarious thing to do, to the point that I want to do it. Let's do it. Okay. Let's reorder it in code though. We know this is the order we want. We can then sort by I really like that suggestion. Order. Okay. And they're gonna build, those are actually gonna be columns in there. A little movie incantation. Just formatting that. I hate really long lines. That. Okay. Scanner. Order. And oh man, this is something I haven't done in Ruby for a while. Ruby. And 6. Okay. So I've either got it the right way or I've got it backwards. This feels like backwards. I should just look. Scanners. That. I didn't do the right thing at all. Oh, it's because it's scanner. Lol. My scanner was also in the string. Mill with 17. Interesting. What am I doing wrong here? Beta. Yeah, this looks like. Don't forget scanner 0 is in your list. Oh, thank you. Okay, so scanners, I didn't want to reverse. Okay, so now I have them in reverse order, which is funny. It'll probably take a long time. Well, that was a very good suggestion. This is now potentially workably speedy. Still pretty slow, but yeah. 2 more left. And here we go. Minute 17. Day 19 cheating to make it faster. I really want to come back later and resolve this, but I also want to eventually eat dinner. So, let's try our hand at part 2. Oh, I'm just forgetting what key bindings to use. Okay, A19 part 2. So we know it's supposed to produce the Manhattan distance. I'm just going to do this into here. We just need to do the mails. I wouldn't mind refactoring it after, but so this is the so I can take one of the, how do I do this? So if I take one of the points, I can figure out all of the is there a way for me to just like write down the coordinates of the scanners as I go? Yeah, scanners your location, then each of the others you already have as a variable somewhere. Yeah, so let's add a location to our scanner. Or yeah, and I can use this isn't, oh, I've not recorded here though. So like this others you already have as a variable somewhere. Yeah, I have them as a variable somewhere at some point, but I'm not recording them, am I? It's like this is the distance between or does this tell me the location? Is this just the location? Yeah, okay. Whew. I was thinking I was going to have to do more math. Yeah, that's just the location of the scanner. And we just know that the first one is going to be 0, 0. So I just need to first location equals So, oh no, I edited this one. I should have just refactored this first so I didn't do what I just did. So keyword location shouldn't have been required. Okay, and so now we have resolved. Should be a set of these, and they should all have locations. And then I can. It seems like. How is that so many? Only resolved is a set. Size 5. Oh, it's all the orientations inside them. Right. Okay. Getting distracted. Let's map these to the location. And then is there Manhattan? This is the thing I can do with vectors. Do I just need to implement that? It's just MSAB. Can I just destructure these somehow? Combination to map. Yeah, okay. So that could be pairs, and then I can probably just 2A them and zip them together. A, 2A, zip, B, 2A, and then sum them by doing more variable shadowing. Do A minus B absolute. The right value. Oh, yes. Okay. Horrible, but let's just run a test. Make sure everything's good. Actually, wouldn't mind knowing that we haven't broken part 1, but we'll check that in a sec. This is going to take not very long because I solved the wrong part of the puzzle. Cool. In a couple minutes, we should know the answer. Almost there. That's a big number. All right. I mean, I think I might just leave it there for today and go eat some dinner. But that was a fun one. I still might have to come back, optimize this thing, try and figure out what the optimization you're trying to tell me was. Yeah, it's a good puzzle. I don't want to put statements in here. Oh, and I should make it focus, did I? Yeah, it's gonna like single-handedly make my test slow. Yeah, this one file. Oh, now I got slow tests. Well, thanks everyone, especially Nark for all the help on this one. I plan on being back again tomorrow night to do maybe day 20 and maybe 21. I don't know, whatever I got time for. I've heard day 20 was a bit of a easier one than this one. So, yeah, thanks everyone. Later.